In this video, I'll show you how you can get your PCB and hardware designs manufactured and assembled. We'll go through which files are required and how you can generate these files. For example, for manufacturing, we'll look at Gerber files, we'll look at how to generate stack-up information for controlled impedance and so forth, but also looking at the assembly side. What files do we need, such as bill of materials, component placement files, assembly drawings, how we create those, and which ones we need to send to the manufacturer, and which ones may be optional. The boards you're seeing here were all manufactured and assembled by PCBWay, and I went through the exact process you'll see in this video to generate the relevant manufacturing and assembly files. As you can see, some of them have 3-hole parts, most of them are SMT parts, double-sided assembly, so components on the top, components on the bottom, as well as customized stack-ups because I had several controlled impedance requirements for some of these boards. I'd like to show you all this information as it can be rather daunting if you haven't done this before, but to make sure all your assembly and manufacturing processes go smoothly, it's very important that you take care with this design step. Without further ado, let's get started. Thank you very much to Altium for sponsoring this video. I'll be showing you how to export your manufacturing and assembly information using Altium Design in this video, but of course these tips and tricks apply to any ECAD tool of your choice. If you'd like to follow along and give Altium Designer a try for yourself, make sure to check out the link in the description below, or go to altium.com/YT/Phil's Lab to get yourself an Altium Designer free trial, which includes all the core Altium 365 features. Thank you also very much to PCBWay for sponsoring this video. As I said at the beginning of this video, the PCBs I have made for this channel are manufactured and assembled by PCBWay, and I'd also like to guide you through the process when you'd like to get your PCBs manufactured and assembled by them, what files you need, how you communicate with your manufacturer of choice. I'd like to guide you through this process looking at two examples. One is this FPGA hardware accelerator board, which is an M2 keyboard featuring a Xilinx Arctic 7 FPGA, some DDR memory, with double-sided assembly, some special requirements, for example this edge connector, some edge plating and so on. A board I'm having manufactured at the moment will be an educational dev board featuring the Xilinx Zinc system on chip, so essentially half MPU and half FPGA, a gigabyte of DDR3 memory, Ethernet, USB, various power supplies and so on. So quite an involved design, which I'm having manufactured and assembled at PCBWay as we speak. For both of these designs, of course, I had to generate manufacturing data, and of course, for any design you want to manufacture, you have to generate this data. Before you get to this data manufacturing step, however, you really need to make sure your design is checked thoroughly. This is starting by going through the schematics, it's looking at the PCB design, or the routing, make sure you've designed the stack up properly, you have no splits, and so forth. Of course, I won't be covering this in this video, but this is something you have to do, is really thoroughly check your design. I usually spend at least a week or 2 weeks just checking the design once I've finished something, for example, as complex as this. Make sure also to run your ERCs and your design rule checks before you proceed to your manufacturing stage. I can't stress how important this is because we want to make sure our designs work first time. Another point I'd like to stress is, especially as we're currently still within a global chip shortage, is that you made sure that you have all of the parts you need, at least in stock, or in stock with your preferred PCB manufacturer or assembler, that you know that you can have this board produced, you have all the relevant components. And this is especially true for active components, for example, the DDR memory, or whatever microcontroller processor you might be using in your design. And this should have happened well before you started even thinking about your PCB design. Make sure you have all your parts in stock, even though you might be having a turnkey solution with your PCB manufacturer and assembler that they order parts for you. These days, it's incredibly important to have your parts in stock before you proceed. Not just for manufacturing, but also for assembly, it's incredibly important to know which manufacturer and which assembler you'll be using. Some of you might be doing this in-house, as it is the assembly part of this process, but more often than not, you will want to have your PCBs manufactured and assembled by a third party. Just a simple Google search looking for PCB manufacturers, there are many of these companies all over the world, be that in Europe, USA, Asia, and so forth. This is incredibly important to know also before you even start the PCB design, layout, and process, making sure you know what your manufacturer is capable of, both with the terms of manufacturing, for example, clearances, drill hole sizes, and so on, but also assembly. Can your chosen PCB manufacturer even do double-sided assembly? Can they assemble 0201 parts, which are tiny, or BGA parts? Do they have equipment such as X-ray machines and so on? This is very important to look at before you even touch the PCB design. And this, of course, happens well before manufacturing. In the case of the channel sponsor, PCBWay, they are more than capable of doing the designs we're presenting on this YouTube channel. For manufacturing capabilities, the easiest thing is just to go to their capability section, for example, looking at the PCB capability section, and any manufacturer will have this on their website. Here you can see the layer counts they can do, what materials, board thicknesses, dimensional tolerances, drill sizes, and so on. And this of course has to align with your design. As is always the case, you should communicate with your manufacturer if you have special requirements and so forth. And additionally, you should stay away from any minimums they have. For example, if the smallest drill hole size they can do is 0.2 millimeters, of course you should try and aim to be above that if your design allows. Some PCB manufacturers might also have more advanced capabilities, which can't then be pooled with other designs, so they'll be more costly. But then of course you can do pretty cool stuff such as HDI designs, 3mm spacings, and so on. Not only should you be aware of your manufacturer's capabilities when it comes to manufacturing, so creating the PCBs, but also with PCB assembly. Any manufacturer should have this on their website as well, or when you speak to your manufacturer, they should be able to give you this information. This is with regards to PCB assembly capabilities. As we said before, not all manufacturers will be capable of placing and soldering such small parts such as O201s or even fine pitch BGAs. They might not have the equipment there. So it's incredibly important to speak to a manufacturer, make sure you know what their capabilities are and so on. For example, PCBWay has X-ray inspection for BGAs, QFNs, and so on. And they can also assemble O201 components, which is important for the designs I'll be showing you in this video. So make sure to triple check that before you even get started making your PCB, of course. We'll get back to the quoting page later to show you the complete process, but with regards to assembly, there's also the option usually with PCB manufacturers and assemblers of how you deliver components to them. And this is also, of course, important if you have maybe expensive parts in stock yourself or parts that can't be sourced anywhere. The most popular type of assembly is turnkey, where your PCB manufacturer and assembler will buy the parts for you after you've supplied them with a bill of materials. You can also do a mix where you send them some parts you have on stock and let them buy the rest. It's just important that you are aware of these different assembly or procurement methods. In any case, let's assume we had chosen a PCB manufacturer of our choice. Of course, in this video, this is PCBWay. We know the PCB is manufacturable and they have all the assembly machines available to place these small parts and that everything can be handled by them. What's then left up to you, the designer, to do is generate the necessary manufacturing and assembly information. So let's go through this step by step. I have my PCB open in Altium Designer. I'm just going to use this setBret reloaded. Of course, I've already made these manufacturing files, but I'd like to show you in detail how I did this and what files you should prepare. Assuming, of course, also you've thoroughly checked your design, went through the schematic and PCB, the first thing I typically do is generate my Gerber files. Any PCB design software will be, of course, capable to do this. Keep in mind there are also more modern formats such as ODB++, but I still quite like to use Gerber X2 files. In Altium Designer, in your PCB view, go to the top left on File, then Fabrication Outputs and Gerber X2 files. This will bring up this dialog box. And there's a couple things we need to pay attention to. Predominantly, this is the units in the top left. If you're in the US, you'll probably specify this in inches, and if you're in Europe, for example, I'm in Germany, or wherever your PCB manufacturer is, or in China, you should probably specify this as millimeters. This will be written in the Gerber files in any case, but it's important also to make sure you're in line with your manufacturer, saying your units used are millimeters. And this will be also important for your assembly drawings later on. So I'll select millimeters, I'll select the smallest resolution I can, and Gerber file names extension, it's fine just going with the generic .gbr. There's other file names extensions such as GTL, GBL, give more information about the layer type. For example, GTL is the top layer, GBL is the bottom layer, there might be overlay layers and so on. I typically go with GBR. A very important aspect is now selecting which layers you would like to export. In the PCB design, if we look at the bottom, we can see the layers we have. We have all these various copper layers, for example, layer 1 signal, layer 2 ground. But we also have various other layers. For example, silkscreen might be the top overlay layer, which is this yellow layer on the bottom right. These, of course, we want to send to our manufacturer. We want to make sure we send all the copper layers, the board outline, silkscreen, solder mask, and so on. Let's go through one by one. We have the profile layer, which is the board outline. You definitely want to send this one. Then we have all of the copper layers, and these should all be checked, of course. We want to make however many layers we have in our board. This happens to be a 10-layer board. Then we have the silkscreen, legend, or overlay layers. If you're only using, for example, the top overlay or top silkscreen layer, you would simply check the top one and deselect the bottom overlay layer. There's no use in sending your manufacturer layers they're not going to use. They're going to discard them anyway. In this case, I am using top and bottom silkscreen, so I'll select that. Solder mask, I want to select for top and bottom. And paste is the solder paste layer, so for assembly, if you're just getting boards manufactured without assembly, you don't have to send them the paste layers. If you're doing single-sided assembly, you choose only the paste layer where your components are soldered on, usually the top layer. Since this is a double-sided assembly, I need to send both the top and bottom paste layers. Then we have various miscellaneous layers here, mechanical layers, which might be used in your ECAD tool for 3D models and so on, or courtyards. We typically don't have to send any of these as well. What I do like to send as well are the top and bottom pad masters, indicating where the component pads are. Lastly, and importantly as well, we need to send drill Gerber files, so the location and sizes of via drills, through-hole drills, and so on. These are typically separated in plated through-hole, so PTH, and this will include vias, this will include, for example, through-hole connector pads, and we also have NPTH, which is non-plated through-hole, which might be mounting holes which aren't plated, tooling holes, and so on. So these two drill layers we also need to export. Other than that, there are some advanced options, but typically you can leave them as they are, unless you have specific requirements. Click Apply, and Altium Designer or your ECAD tool of choice will start generating these Gerber files for you, or plotting them. Usually what is then opened is known as a CAM viewer. This is the tool which allows you to view Gerber files. I highly encourage you to check your Gerber files thoroughly. A lot of the times I might check little inconsistencies or maybe even little mistakes just by looking at my Gerber files. It gives you a slightly different view of the layers and shows you, for example, what copper will be actually left on the board or the layers. So what I'll do is I'll right click and select all off, which hides all the layers, and go through the layers one by one. For example, my top copper layer, I can then zoom in, have a look. Okay, do the clearances look right? Does everything look like it's been plotted correctly? And so on. I could of course also turn on the PCB copper layer and also turn on the drill layer, which allows me to look, okay, have all my drills been plotted properly? And so on. It just lets me spot, rather crudely, some mistakes I might have made or something which I could maybe tidy up a tiny bit. So in that way, I would select individual layers. For example, my ground copper boards, this is what I always really encourage as well, to make sure I don't have too large ground or reference plane cutouts. For example, that I always have slivers between my via drill holes and so on, and that I don't have too many of these large cutouts. You can, of course, also inspect the pads layer or the solder mask layers, make sure you have wide enough slivers between the IC components that this is actually manufacturable, looking at ledge and so on. So I really strongly suggest you take your time checking these Gerber files. If we look at where Altium has placed these files, these are typically in the project outputs folder. We can see we have all of these different Gerber files, for example, the top copper layer, inner layer 1, 2, 3, and so on, the paste, and everything we selected in the dialog box. What I then typically do is simply add that to an archive and give it a sensible name. For example, project name -Gerber, maybe revision number, and so on, of course. This zip file or RAR file, I would just send straight to my manufacturer if I simply want my board manufactured. However, we might want more than that. We might want to have a different stack up. We want to have controlled impedance traces, which we need to indicate, maybe edge plating and so on. And for that, the Gerber files aren't enough. So we need to create some additional information. So let's do that now. Taking as an example this other board, this FPGA-based hardware accelerator, same as with the other board, I have various high-speed traces. For example, I have PCI Express, I have these DDR signal lines, and so on. And for these, I require controlled impedance traces, meaning these traces are of a certain thickness. The spacing between layer 1 and the reference plane below is a certain spacing, which is governed by the dielectric. And I have to choose certain dielectric constants to meet this controlled impedance traces. For example, that these lines are 50 ohms controlled impedance traces, for example. If we go to design, layer stack manager, I've entered this information into Altium Designer. So I said layer 1 is a copper layer, it's 1 ounce thickness. Then I have a prepreg of a certain type, for example, layer 2 ground, layer 3 signal, I have various cores, dielectrics, and so on. I didn't just pull this information from thin air, I spoke to my manufacturer, PCBWay in this case, asked them what their capabilities are, what their standard stack-ups are, materials they can use, and so on. And this is what you have to do when you want controlled impedance. You should talk to your manufacturer, see what materials they have in stock, and what they can easily produce without adding cost, too much at least. The way I would include that in my manufacturing information is by placing a text file or PDF, whatever you prefer, into your Gerber archive, the one, for example, we created earlier. As you can see here for this FPGA hardware accelerator, I added a manufacturing info text file within the Gerber archive. And when I was placing my order or communicating with my manufacturer, I would send them this archive and say, please look at the manufacturing info because I require controlled impedance and I require a custom stack-up. Opening this text file, we can see some key information I've put in to make sure this isn't missed. This board had to be a thickness of 0.8 millimeters. I put that right at the top. I said I also need an edge connector, and I included an image showing that. So I'd include them another screenshot just to make sure, okay, where there are no misunderstandings, that I need an edge connector, where this is, and so on. Same goes, for example, for castellators, holes, and so on. Provide as much information as you think is necessary to convey your design intent. Then you might include information such as board size, how many layers you have, what materials, minimum track spacing, and so on. This is always good information to convey. Even though, for example, when using an online quoting system, you would enter this information here anyway. The point is that we don't want any information to get lost. It's easy maybe for a representative of the company to look over some of these details, but then a CAM operator or the person checking the Gerber files might see this information and catch a mistake. Make sure to be thorough when sending off your designs because you want to minimize any mistakes that happen there. In any case, I've also then indicated that I require impedance control for this board. I let them know what type of impedance control. For example, single-ended traces, I need 50 ohms with a certain tolerance. And I say I have some microstrip, so some traces running on layer 1, which is a signal layer, and these are referencing layer 2. And I have a target trace width of, for example, 0.08 millimeters. I have the same on the bottom layer, but I also have strip line traces, again, single-ended 50 ohms with a tolerance of 10%. So I'm letting them know I need impedance control, what type, what target, what tolerance, and which layers, and which target trace widths. And this is to give them an idea of what the requirements are, and then your PCB manufacturer will know best how to adjust the dielectrics, the spacings, dielectric constants, and so on to make sure we can get close or meet these requirements. I do this the same for differential, various differential traces, but then I also suggest a stack up based on the materials I've seen from their website. For example, with PCBWay, they might have some various material lists of what prepregs and cores they have and which ones you can use. Maybe they'll usually also include dielectrics and so on. So using this information, you can then attempt a first stack-up suggestion that might meet their requirements. Of course, to do that, you need some sort of stack-up or build-up solver. Nicely enough for Altium Designer, this is included as a 2D field solver. So I can enter my material thicknesses, for example, I can enter the dielectrics, and then in the impedance tab on the bottom, Altium Designer will calculate what impedances result from that given a certain track width, for example. So typing in 0.08 millimeters, I get an approximate impedance of 47 ohms single-ended. I can do the same for differential, where I also have to adjust my trace spacing to meet that target. So in this way, I try to maybe aid the manufacturer a tiny bit, say, okay, I've looked at your materials, I have these targets, maybe this is a possible stack up, so they know where to start. Of course, the manufacturer will know best what they can produce, if they even have these materials, how easy this is to produce, and how much cost this might add. But I typically like to send a suggested stack up just to get the ball rolling, so to speak. So this is what I've indicated here. I would always indicate which layers are what file names. So layer 1 will have the file ending copper signal top, layer 2 will have copper signal 1, and so on. Again, always trying to convey design intent, making sure there's minimal chance of error when you're communicating this information. You don't want this to be the downfall of your design, for example. In any case, this is the minimum information I would send, for example, for a more complicated design as this, where I require custom stack up, I might require impedance control, castellated holes, and so on. Essentially all the information they might need to produce this board. So you might send this information to your manufacturer, and you might get something back like this, an engineering question. They've read and acknowledged the manufacturing info you sent, for example, as this text file, and a suggested stack up which I sent to them. What they might send back is then their suggested stack up based on your requirements, for example, the thickness requirements, what dielectrics you might want, thicknesses, and so on. Then they will also send you back the actual trace widths using their impedance control calculator. Their impedance control calculator is the one you should trust, and those are the trace widths you should use at the end of the day. For example, they'll send you back on the outer layer. Layer 1 is your trace layer, layer 2 is the reference. This is in mils, not millimeters, about 4 mils. Impedance 50 ohms, and they say, please adjust this to 4.1 mils to make sure we reach that target impedance of 50 plus minus 10%. And they'll do that for all the controlled impedance traces I want. And in this way, you've communicated with your manufacturer. They've provided updated information, which is close to your original guess, if you've done it right, but you still need to adjust traces in most cases. You can either let your manufacturer do this for you, but I'd strongly suggest adjusting your design to meet your manufacturer specifications. So then I'd go back to Altium Designer, input this new information from my manufacturer, input the new impedance calculations, and then change the trace widths on my board, for example. Once you're happy with your manufacturer information, you've generated the Gerber files and any additional information that can help your manufacturer out, it's of course time to generate assembly information, assuming you want your board assembled, that is. What I encourage you to do is, even in the schematic stage or when you're creating your component libraries and footprints, is to include information on the part. For example, jumping to a random schematic page and clicking on one of these resistors, although there's only 4.7 kiloohms and the designator indicated on the schematic are 403, on the bottom right side in the properties panel, you can see I've added a manufacturer name, I've added a manufacturer part number, and a distributor link as the 3 main parts. And I've done this for every part here, so for this capacitor, for this transistor, and every single part on the schematic. The reason I did this is then I can simply generate a bill of materials and don't have to manually type in any information anymore. A bill of materials is essentially just a list of components given the designators, so I'll have R400, 12 kiloohms, I'll have the manufacturer number, and so on. And I want to generate that to make sure my PCB manufacturer or an assembler knows what components to place on the board, which components to buy, what quantities, and so on. Depending on the ECAD tool of choice, of course, the workflow is slightly different, but I would go to Reports, Bill of Materials, which brings up this dialog box, and have various columns and rows. The rows indicate a unique component. So for example, row 19 might be this 3.3 microhenry inductor. I can see the designator, what footprint it is, what quantity I have per board, the manufacturer part number, and distributor link. And this is the bill of materials. So just a list of all the components I have on this board, including designators, manufacturers, manufacturer part numbers, and where you can buy this component, as well as the quantity. In Altium Designer, you can also go on the right-hand side on columns and select various other columns depending on how you organize your libraries and so on. But as a bare minimum, I'd want a comment or a value, so saying this is a 47 nanofarad capacitor. As a minimum, I'd want a description, what this part is. Designator is very important. Footprint, I would definitely include as well. Libref is essentially just a library reference, and that can be taken out. So I'll just deselect that. Quantity, of course, very important. Manufacturer part number, and distributor link, I would all include. So this is a minimum bill of materials I would send over. I can export that either as a comma separated value or Excel. I typically go with comma separated value because that allows anyone to see it. Then export, and I'll just call that by project name -BOM or BOM, bill of materials. I can then open this exported bill of materials, and this is exactly what we saw in Altium Designer. Just comma separated values, which includes all the relevant information to source these parts, as well as what parts need to be on the board and at what quantities. Of course, you can include pricing information, you can calculate how many SMT parts you have, how many through-hole, and so on, but this as a bare minimum is what I'd go with. For machine assembly, or this being automatically assembled and not by hand, which for this kind of board you would definitely not want to do by hand, we also want to include information for the pick and place machines of where to put the individual components. This includes the XY coordinates of certain parts. This includes the XY components of all of the parts, their rotation. For example, for ICs, this will be important that the pin 1s align on the board, as well as if it's on the top or on the bottom layer, for example. In Altium Designer, the way you do that is go to the top left, File in your board view, then Assembly Outputs, and Generate Pick and Place file. What I typically like to include in my pick and place file is, of course, the designator, and this has to be in there, the layer, the X coordinate, and the Y coordinate of the component, as well as the rotation. I'll typically also include a comment or the value, which gives you the component value. For example, if this is a 4.7 microfarad capacitor and so on, as well as a brief description. Now, while this might not be used directly, it's good as kind of a double check to make sure that if this is being done by hand, for example, or manually, that we can double check that we're placing down the right values. Of course, this should be linked with the bill of materials also by your PCB manufacturer and assembler, but I would make sure to keep this information in. Other than that, of course, you need to choose your units because you're having coordinates here. Millimeters is typically what I'd go for, of course, depends on which country your manufacturer is as well. Format, comma separated value as always, and then simply just click OK. In your project output folder, then you'll see that we have this pick and place file generated, and I'll just rename that to my project name -CPL component placement file. Opening that up, we can see this is just line by line, every single component we have on this board, what value, X and Y coordinates, and what rotation, and so on. This video is in no way associated with or sponsored by Eurocircuits, but I'd like to show you a very useful tool that I pretty much use for every design before I send my manufacturing data or assembly data to my manufacturer of choice. Eurocircuits has a really nice online visualizer and tool for checking footprints and making sure there aren't any assembly problems just before you submit the files to be manufactured. Not only is this good to visualize, for example, the PCB, the Gerber files, but also, as I said, for footprint checking. go to Eurocircuits, the PCBA visualizer, and then going to the CPL editor. Nicely enough, if you click on various components and footprints, for example, the resistors, you can see if their footprint database matches your pads, for example. Also checking, for example, this QFN IC. This is where I would go through and check, making sure the footprints cross-match between their libraries and their references and between my libraries and references. This is especially useful also for through-hole parts. Also maybe for BGAs, clicking on them, I can see, is pad 1 aligned? Are the pads the right sizes? Did I mess up something with the footprints and so on? So this is something I'd highly encourage after you've generated the Gerber, bill of materials, and footprint placement files to upload it to their site, just to do another sanity or general check for your PCB design files and so on. With our files being generated, that means the manufacturing files, Gerber files, which include all the layers of the Gerber plots, as well as additional manufacturing info, as well as the bill of materials, which contains all the components we're using, designators, manufacturer numbers, and so on, as well as our component placement files. This is the bare minimum I would send to a manufacturer to get my boards assembled and manufactured. However, especially for assembly, it pays off to go that slight bit further and provide assembly drawings. Many of manufacturers will also want you to provide these regardless as a necessity. PCBWay doesn't really require assembly drawings, but I always provide them in any case, and I suggest you do the same. This again depends on your ECAD tool, but most ECAD tools will have support for this. Let me show you what a basic assembly drawing looks like and how I would generate one in Altium Designer. Before we generate an assembly drawing, let me just show you what an assembly drawing or very basic one might include. And these are the absolute minimums. For this, I'm using the Altium Designer's Draftsman feature, and I'll show you how to generate that in just a second. I'd include the name, saying this is assembly documentation, maybe some basic information such as lengths, widths, thicknesses, and so on, who it's drawn by, maybe your logo, and so on. I will always place some sort of realistic view, for example, Altium Designer's 3D view, on my assembly drawing, just to get the assembly operator familiar with what this board looks like, and I can also identify very easily, for example, through-hole placements, which side, which components go on, just as an overview. I then also like to include isometric views because this gives me information also about depth, the sizes relative of all the connectors, also orientations with pin 1s, component sizes, which sides do my components go on. So I think this is a very nice view to include as well, especially for manual assembly. The most important drawings, however, are the assembly top and bottom drawings if you are doing double-sided assembly. Essentially, they are top-down views and bottom-down views, so to speak, 2D views of your boards, and a simplified view just with bounding boxes for the components, as well as component designators. For example, the top-down view, I would have a bounding box of, for example, if this system on chip, and in the center, this is the component designator. I'd do this also for all other ICs, as well as all passives, for example, these resistors, capacitors, and so on. I also like to include the silk screen on the board as well as the main holes in the board just for alignment purposes and cross-checking. This is a view I would always include. Not only component designators, but also pin 1 and, for example, diode polarity indications I would put on this diagram as well. Well, pin 1 indicated by a dot, or, for example, diode polarity, in this case, the anode indicated by a plus. And I would then maybe make a little note, for example, on the top right on this diagram, saying what these dots and pluses mean. I do this for the top drawing and for the bottom drawing as well. The nice thing about when exporting these to PDF, which we'll do later on, is that these are essentially vector graphics, so I can zoom in as far as I want and still have pretty good clarity when it comes to reading this text, so when you're printing this out or doing this on a computer screen. But these drawings, so assembly bottom, top and bottom, isometric and 3D, is essentially the minimum I would include. Let me show you how I did this. In my Project Explorer, I simply right-click on my project, click Add New to Project, and then choose the Draftsman document. I'll just create a default drawing, and I get greeted with this empty page. On the right-hand side, I can set various parameters such as the default document font, grid sizes, and so on, but for now, this is just a basic demonstration. The nice thing about this Draftsman feature is that it's directly linked to your PCB design document. So anytime I make a change here, all I have to do in my Draftsman to update is right-click and import changes. So let's play some drawings to see how easy this is. I click P on my keyboard for place, and I can put down these different views. And there's many views you can put down. For example, looking at sections of the board, giving us the layer stack, giving us transmission line tables for controlled impedance, and so on. For example, if I want to do a realistic view, the 3D view, I would go to Additional Views, Board Realistic View, and that instantly pulls it from my PCB document, and I can drag to increase and decrease On the right hand side, I can change the view to top, bottom, custom, and so on. To place an isometric view, I do P, additional view, board isometric view, wait for it to pull all the data, and then I can place my isometric view down wherever I want. I can also increase, change the scale, for example 2:1, and it nicely annotates that as text as well. I can of course choose different views, which is really handy if you want to highlight certain aspects of the board, maybe certain placements which might be visible on a different view. For example, like so. For assembly drawings, it's the same procedure as before. Press P and then just add a board assembly view, and then change the scale, for example 2:1. We'll just get rid of these other views for clarity. As you can see, initially it's quite cluttered, so we have to clean it up a bit. First thing I do is click on the view. On the right hand side, I scroll down to component body, and I can, for example, just choose a bounding box, and that already cleans this up quite a bit. If I want to show silk screen, all I have to do is on the right hand side, say with or without components. I can change the color of the silk screen, and so on. So you can see with a couple mouse clicks, I can create really cool assembly drawings. Individually, I can also change the components. For example, I click a component, I can change maybe that the designator is on the top, and so I can customize that to however I want. And of course, I would do the same thing from the bottom layer. I can add multiple sheets in, for example, and then annotate with however I want. But again, as a bare minimum, 3D drawing, isometric, and assembly top and bottom views is what I'd suggest. Once you're happy with that, all you have to do is go to File, Export to PDF, and then that PDF document is what you'd send to your manufacturer. So in your project output folder, you should now have your Gerber files zipped up, what is a rough archive, component placement, the bill of materials, as well as I've placed this PDF file in a zip folder as well, which is just the assembly information which we saw from the Draftsman document just now. So let me show you how I then place an order, for example, at PCBWay. PCBWay, this will be an advanced PCB. I'll type in the dimensions of the PCB, how many I want, let's say 10 of these boards, and this is a 10-layer PCB of 1.6mm thickness. Now we have to type in all the specifications. I want a through-hole board, you have a certain board spec, quantity, layers, materials, thicknesses. Then we have things such as minimum track spacing and hole sizes, and this of course depends on your design. I know from my design I need 3mm spacing, smallest hole size is 0.15mm. I'd like a matte black solder mask, yellow silk screen, immersion nickel gold finish, these various copper settings and so on. And then I also have these additional options. For example, impedance control is something I need a custom stack up, and that's pretty much it for this PCB. In this other special request box, I would then say, please see the manufacturing info text file, which is located in the Gerber archive, which includes information such as controlled impedance, stack up, and so on. I also want assembly for this board. So at the end, I go to assembly service, board type, I want them shipped to me as single pieces and assemblies both sides. I want PCBWay to buy all the parts for me, and I would like 10 of these boards, 10 out of 10 of these boards assembled. I don't really have particularly sensitive components. Of course, they'll pay attention anyway with all the ICs. Then I have to usually enter these other parameters, such as number of unique parts, which will drive up the cost, the number of S&D parts, BGAs, and so on. And this is something you can extract from your bill of materials. It turns out that for this board, I have 56 unique parts, 409 SMD, 13 BGA and QFN parts, and 4 through-hole. Then in the additional options, I will also put, please see the assembly info archive to find assembly drawings. Again, just trying to convey that I've put more information in than maybe is needed by default. Then I would save to cart, and this is where you see where you have to upload all our files. You have to load the Gerber files, parts list, our bill of materials, Centroid, which is our CPL file, and then I'll upload assembly drawings as well. So uploading Gerber files, all I have to pick is my Gerber archive, my parts list, I select the bill of materials, my CSV, Centroid is my CPL, and other files I'm just going to include my assembly drawings, which I've put into the zip file over here. And this is all I need. And then I simply click Submit Order Now. Then a PCBWay representative will come back to you in case you might need to make changes to the stack up, to your trace widths, and to double check that the bill of materials and the parts they're going to source are okay. And that's pretty much all there is to it. Remember to always speak to your PCB manufacturer way before you start your PCB design and layout to make sure what is possible, what they can do, and how you can work together. Thank you very much for watching this video. I hope it was helpful, and I hope it enables you to get your PCBs manufactured and also assembled if you wish. These were just the basics, and of course you can include more information such as net lists, mechanical drawings, and so on, but the information in this video is pretty much enough to get most PCBs manufactured and assembled these days. Remember to speak to your PCB manufacturer and assemble to see what's possible. In any case, thank you very much for watching. If you liked the video, please do leave a like, a comment if you have any questions, and don't forget to subscribe. Thank you very much, and look forward to seeing you in the next video. Bye-bye.